All right, so we are on our last two trig functions. We've done, sorry, there's a smudge on the screen. We've done sine and cosine, tangent and cotangent, and last but not least, we have secant and cosecant. So let's start with cosecant. And a little disclaimer, secant and cosecant are what I say a piece of cake if you know how to do sine and cosine. Secant and cosecant are the reciprocals of sine and cosine. So what we're going to do is actually graph sine and cosine first, either physically on the paper or in our heads, and then use that to get secant and cosecant. So here we go. All right. This is cosecant, right? So pause, and if you need to pause the video at any point during this lesson, please do that, of course. What is cosecant the reciprocal of? And hopefully you're saying sine. So what I'm actually going to do is I'm going to take the equation that I have here, and even if there's transformation stuff in there, so if there's an a value of 2, a vertical shift down 3, whatever it is, I'm going to repeat it all, just copy it all. But the only difference is I'm going to change the cosecant part to sine. So if there was like a +3 at the end, I would add a +3 at the end to my thought bubble here, okay? So just change the cosecant to a sine, copy everything else exactly the same. And then what you're going to do is you're going to graph this thought bubble, all right? And you would do this like kind of lightly because this isn't actually what we're going to use. I don't think I can go lightly. I'll just use a really light color. So I'll use like a light blue here. So I'm going to graph sine of x. So what does sine of x look like? It starts here, right? The period is 2 pi. It ends here. Middle dot is here. The amplitude is 1. So this one goes up. This one goes down. And I'm going to graph it, copy and paste. That's one cycle, but I'm going to graph it the whole way through. And then when you go to connect the dots, either don't connect them or connect them very, very lightly with like a dashed line like this. So I think that's what I do on my answer keys. You can also just not connect them at all. I'm going to actually not connect them this time and show you kind of what happens here. So now I'm going to do my actual function in, I'll do it in red. So now, reciprocal. Think about what we did when we did reciprocal of tangent and cotangent. What happened to every x-intercept when we did reciprocals for tangent and cotangent? Every x-intercept became an asymptote, right? So every x-intercept is going to become an asymptote. So those light blue dots, they're not actually points because this is an asymptote. So if you don't have those dots there, so for example, like this, that's great. All right, that's actually what it should look like. If you have the blue dots, fine. Just keep them very light because they're actually not supposed to be there. All right, it's supposed to be an asymptote. Okay, what happens with these other points? What's the reciprocal of 1, right? The reciprocal of 1 is still 1. So that point and this point over here, they're not going to change, right? Same thing with the negative ones. What's the reciprocal of -1? Still -1. So these points are not going to change. Now, just watch for a second. If I put back in that dashed line of what sine was, if I take any point on this graph and do the reciprocal of it, what happens is it reflects up. Okay, so like that dot would reflect to up here. This dot would reflect to up here, right? Those reciprocals, is that's how they would be. So this whole curve basically becomes a reflection when you do the reciprocal, and it ends up being this curve, right? Now you don't have to plot those points. Okay, hopefully you were just watching. I'm gonna erase all this. You don't have to plot those points, but you need to understand that that sine curve, all the reciprocal of those points end up creating this curve. And they're getting close to the asymptotes but not touching them, right? Now the same thing right here where that curve was like this, those points are going to reflect and they're going to come down like that. Okay, that's how the reciprocals end up looking when you graph them. So this is what cosecant looks like in red. Everything you see in red is cosecant. So there's this big gap in the middle there, right? In between -1 and 1. There's no points there on the graph. So again, let me go back and I'm going to completely do this from start to finish fast so you can kind of see what you would do. So if I were doing this question, I would graph my sine points, right, all the way through, copying and pasting. I would then turn every x-intercept into an asymptote. And I don't, as a teacher, I don't mind those dots being there. I understand that was just for your work. And then with all the other maxes and mins, this dot's in the wrong place. With all your other maxes and mins, you just create curves, and those curves go away from the x-axis. Common mistake is like someone will have this one go down like that. Okay, that's a no-no. Okay, so whenever you draw your curves, your maxes and mins basically become the vertex of a parabola, and that parabola opens away from the x-axis. So it should never be touching that x-axis. And there you go. That's cosecant. Now, what's the period of cosecant? The period of cosecant is 2 pi. This is your main cycle. Right? So there's 5 critical points still. It's the 3 asymptotes and the 2 vertices of those parabolas. So I'll highlight them for you. So this is all your main function. I'm not going to have you guys highlight for this. It was more for sine and cosine, the highlighting, because that's where it gets tricky for me to grade as a teacher. So for secant and cosecant, you don't have to highlight. All right, let's try another one. Secant. So same concept. We'll go through this faster. Same concept. You're going to take a little thought bubble here. Your thought bubble this time will be y equals cosine of x. The period is 2 pi, and my amplitude is 1. Oh, speaking of amplitude, if I asked you what's the amplitude of this, there is none, right? No amplitude, because amplitude is the max, the half the distance of the max and the min. There is no max, there is no min of cosecant because we're going up forever and we're going down forever. So the only 2 functions that have amplitudes are sine and cosine. The only 2 functions that have amplitudes are sine and cosine. All the other 4, tangent, cotangent, secant, and cosecant, no amplitudes, right? So when I'm saying amplitude of 1 here, this is my thought bubble. Okay, so I'm going to graph cosine. It's the parent function, so I should be fast at this. Okay. Whoop. Okay. If you want to connect those dots, you can with a dashed line, right? And then here we go. Every x-intercept becomes an asymptote. It's the same process. And then all these max and min points become the vertices of a parabola that opens away from the x-axis. And that's secant. So now we're going to add in some transformations. I have 2 examples left. So I'm going to take this thought bubble, y equals 2 sine of x. So I'm going to graph that. The period of this thought bubble is 2 pi. The amplitude of this thought bubble is 2. So if you want to pause and try it, go for it. All right, so I graphed my sine function there. If you want to connect it with a dashed line, you can. You don't have to. You'll see that I do that on my answer keys. Every x-intercept becomes an asymptote, every max and min point becomes the vertex of a parabola that opens away from the x-axis. And there you go. Right? If I asked you, what's the period of 2 cosecant of x? You would say the period is 2 pi, right? And the period, again, goes from, it's 3 asymptotes altogether, right? You need the pattern to be repeating itself. So it's 3 asymptotes and then the 2 parabolas in between for one period, okay? And that period is 2 pi. If I asked you what the amplitude was, you would say none or undefined. There's a vertical stretch by a factor of 2. All right, last one. 3 secant of 1/2 x. So thought bubble. And if you do thought bubbles on your quiz, it would be helpful if you actually make them thought bubbles, because then I know what that is. Helps me to check your work, give you partial credit a little bit more if you make a mistake. So I'm going to graph this. The period of this would be 2 pi divided by 1/2, which is 4 pi. Remember, refresher, for sine, cosine, and now secant and cosecant, your formula for period is 2 pi divided by b. But for tangent and cotangent, it's pi divided by b. So tangent and cotangent have the different formula. All right, so I'm going to graph this. Oh, and the amplitude, oops, come on. The amplitude of my thought bubble is 3. So cosine starts up at its maximum point, which is 3. It's going to end at its maximum point, but we're ending at 4 pi. Midpoint will go down, 1, 2, 3, to its minimum point. And then we've got our x-intercepts. Okay, every x-intercept becomes an asymptote. And then, on the homework and practice and review, you're going to see things like with vertical shifts and phase shifts. Right now in this video, I'm just doing the basics. Okay, so when you graph secant and cosecant, what's required in the graph? I should see all the asymptotes. I should see all these vertices of the parabolas, and then the parabolas themselves. So basically what you see here, it's all required. The only thing that's optional is these dots on the asymptotes. If you can get rid of them, then your graph will look even more beautiful. I know this is looks very, I don't know, it's not the cleanest graph. So this is the cleanest you could possibly make it, what you're looking at right now, okay? Optional, if you decide to do it, you could have these dots there. And also optional, if you needed it, you could graph the actual thought bubble of cosine. I would be fine with all that stuff in pink. It makes it look a little bit more messy and sloppy, but it's fine, right? If you need it, please do it. Okay, and that's our lesson. So now we're going to put it all together, start practicing all the different ones, mix them up in different orders, add in phase shift, vertical shift, all that kind of stuff. You guys are doing awesome. So we're going to just review for the next few days with a quiz on Thursday. All right, reach out if you have any questions.